This is a video from section 11.2 in a Calculus 2 class. Let's take a look at the following example. If the nth partial sum of a series from n equal 1 to infinity of a sub n is s sub n, and this is equal to n minus 1 over n plus 1, find an, and then find the summation from n equal 1 to infinity of an. This is a really solid question. So now, here's how it works. Let's write this down. S sub n is the sum of the first n terms of that series. And notice how I wrote an minus 1 on purpose. Now, what I want to do is I want to sum the first n minus 1 terms. So that's a1 plus a2 plus a3 plus all the way to an minus 1. Okay. Now, notice how they're lined up perfectly. So Sn minus 1 is. Now, notice how all the terms up to an minus 1, I'll use red, up here, will cancel out all the terms down here. And then can we agree an is what's left over? Okay. Now, that's the hard part. Now, S sub n is n minus 1 over n plus 1. S sub n minus 1 is replace n with n minus 1. And then I'm going to get n minus 1 minus 1 divided by n minus 1 plus 1. And so I get n minus 2 divided by n. Hope that's okay. Now, S sub n minus S sub n minus 1 is n minus 1 over n plus 1 minus n minus 2 divided by n. Now, the common denominator here is n times n plus 1. The numerator is n times n minus 1 minus n plus 1 times n minus 2. Okay? Now, from here, so I'm going to say S sub n minus S sub n minus 1. Let's look at the bottom. We get n times n plus 1. Let's look at the top. If we look at the top, let's come over here, we get n squared minus n. And then we're going to subtract off n squared minus n minus 2. Tremendous question. Okay? Now, we're in the home stretch. So this is 2 over n times n plus 1. And this is an. Now, I'm going to take 2 over n times n plus 1. This is a over n plus b over n plus 1. So I'm just going to use a little partial fraction decomposition, right? Now, the lowest common denominator here is n times n plus 1. So 2 is a times n plus 1 plus bn. So 2 is a plus b times n, right? an plus bn, and then I'm factoring out the n, right? And then I'm going to add a. So a plus b produces 0. A is going to be 2. And what that tells me is that b equals negative 2. Okay. So now, I want the summation, so we can't lose sight of this. I want the summation from n equal 1 to infinity of an. So the hard part was figuring out this guy, right? Once we figure out this guy, we can figure out that guy. Okay? So it's a telescoping sum. So I'm going to let S sub k, I'm going to sum up the first k terms. Here, let me write this down for a sec. This is the summation from n equal 1 to infinity of, I'm going to get, where to go? 2 over n minus 2 over n plus 1. So replace n with 1. I get 2 minus 1. Replace n with 2. I get 1 minus 2/3. And then I get n with 3. I get 2/3 minus 2/4. And then replace n with k. And I get 2 over k minus 2 over k plus 1. Okay, now let's think about this. So the 1's cancel, the 2/3 cancel. Can we agree that 2/4 is going to kill off the first term of the next parentheses, right? And then can we agree further that 2 over k will kill off the second term in the previous result? Now, what do we have left? We have 2 minus 2 over k plus 1. And so the limit as k goes to infinity of S sub k is the limit as k goes to infinity of 2 minus 2 over k plus 1. But that's equal to 2. So, by definition, we can say the summation from k equal 1, from n equal 1 to infinity of a sub n converges specifically to 2. And that's how we do this example. It's a pretty good example. And that'll conclude this video for Calculus 2. And we looked at a good example of finding an and telescoping series, all that good stuff. Okay, thank you.